Welcome to the building block. In this video, we will be presenting the second video of the second module. Our topic this week is supports and equilibrium. Today, we will be discussing the most common conditions of instability in beams and frames. In the previous video, we learned that for a structure to be stable, it must have at least 3 reactions per member. Now, let's analyze this case. We have a beam with 3 roller supports, which means it has 3 reactions. Do you believe that this structure is stable? Take a moment to think about it and consider the common load cases. Feel free to pause the video and make your assessment. Let's analyze what would happen if we applied a force in this direction. Note that this support configuration is unable to resist this force, and since it has 3 roller supports, it will roll. This makes that the structure is considered unstable. The reason for this is that all the reactions are parallel to each other. At no point do the lines of actions of the forces, represented by these dashed lines, intersect. As a result, when a force is applied in a different direction, the beam is unable to resist it, leading to a condition called rigid body translation. This instability is referred to as parallel reactions. Let's analyze this next case. We have a beam with a pin support at end A, which provides 2 reactions. Additionally, an engineer has added a cable at the same end, aiming to have 3 reactions on this beam. We can see that the engineer fulfilled his purpose. But, is this structure stable? Take a moment to think about it and consider the common load cases. Feel free to pause the video and make your assessment. The answer is no. Let's consider what would happen if, for some reason, a force P were to be applied at a location other than end A of the beam. In this scenario, the force P would create a moment around point A, force times distance, leading to a rotational effect. However, since the beam has all of its reactions only at end A, it lacks the necessary supports to withstand this rotation. There is a great experiment to illustrate the concept further. Have 2 people hold a pencil from one end with their hands close to the end. You create a situation where the support reactions are concentrated in a small region. When a third person tries to push down on the other end, you'll observe that the pencil tilts or rotates quite easily. This is due to the concentrated support cannot effectively resist forces applied at different points along the beam's length. As always, thank you for watching the building block. If you have any questions or need assistance, we'll be more than happy to help you. Join our block, and let's start learning together.